Hello ELM 258 students. This tutorial is going to cover Virtual Lab 3, where we're going to actually perform the same functions that we performed in Virtual Lab 2, except now we're going to do it using Electro-Pneumatics. So in Virtual Lab 2, which I have here, you should have this done before you start this one. We had a 2 push button control cylinder, and then a push button control with automatic return, and then a push button control automatic return with some speed controls, flow controls to control the speed of extend and retract, and then the reciprocal. So we're going to be using the same cylinder, flow controls, and valve. So rather than reinvent the project, I'm going to do a save as. So you should have this saved somewhere. If you go up here, the file menu in Automation Studio is kind of hidden behind their logo up here in the upper left corner. So if you click that and you go to project, you can find save project as, and that will allow you to give a new name to it. And I'm just going to call this Virtual Lab 3 demo. All right, we'll save that. Okay, now that it's saved, I'm just going to delete the stuff I don't need, which is all this here. Get rid of this one and get rid of this. And on this one, I'm going to eliminate the pneumatic controls because I no longer need those. Okay, so the only thing left is the cylinder, the flow controls, and the valve. Now, in order to make this an electro-pneumatic circuit, the valve has to be controlled electrically instead of controlled by pneumatic air lines. So there's a couple ways to do this. We could actually go back to the pneumatic menu and pick a valve that has the solenoids, but I want to show you another way to do this, which is if you double click on the valve and bring up the component properties, it might come up looking like this with some of the specifications of the valve. And if you click on over here, if you click on technical specifications, it brings up a picture of the valve. Now you see the two actuators for either on both sides of the valve are the pneumatic lines. If you click on the symbol here for the pneumatic input, which is the triangle, it brings up a whole bunch of other different types of actuators that you can replace it with. So you don't actually have to create a new valve. So I'm going to change it to an electrical solenoid. And same thing on this side. Double click that, change it to a solenoid. So now we're going to move this over a little bit, make some room. And what we have to do is create an electrical circuit that's going to actuate these solenoids. So it's going to be a separate diagram over here, but we're going to relate it to the solenoid on the electrical diagram. I'm going to show you how to connect that or relate that to the one that's on the pneumatic diagram. Now we have to jump down here to electrical control, and since we're focusing on the HAS200, the HAS200 schematics use the IEC standard, so we're going to go to that area. So we're going to need this is going to be a 24 volt DC control circuit, so we're going to need a 24 volt supply and a 0 volt reference, and then we're going to need a couple of switches. They're just going to be normally open push button switches, and I'm going to name it extend and then another switch right next to it called retract. Now we need the symbol for a solenoid. So that would be under output components. This is the IEC symbol for a solenoid. So I'm going to just put this up here. And I'm going to call this, again, to be consistent with the HAS 200, I'm going to call this A+. And we'll drag another one up here. Call that A-. So A- is going to cause it to retract. A+ is going to cause it to extend. So now we need to connect the circuit. Remember to double click when you're connecting an electrical line to another line. Connect these in. Now what we need to do is to connect the electrical solenoid symbol to the pneumatic solenoid symbol. And we do that by, we've already created this alias for each of the solenoids. And I'm going to double click on the left solenoid, and that's going to become the A+. Now, since I already connected it over here, I click on it, or double click it actually, and then it shows up down here. So that is now the alias for that solenoid. Now I can do the other one. So that on the solenoid, that's called V1, and then the other one is V2, and that's going to be A-. So I do the same thing, double click, and it shows up down here. And when I close it, you see that those labels appear, and they're underlined now, which means that they've been identified, or they've been correlated with another component. This should be ready to simulate, and this is supposed to function just like the first pneumatic circuit. We've got separate buttons, one to extend, one to retract. But in this case, where the extend button is electrical, actuating an electrical solenoid, which is then going to actuate the valve. So let's go ahead and simulate it. Click on simulation. And I hit extend, and cylinder extends, and I hit retract, and it retracts. I guess I have my speeds set, so let's see I'm going to kind of make them sort of medium fast. There we go, like that. All right, extend, retract. Okay, so that's the first circuit. For the next circuit, we're going to be using most of what's here. So I'm going to make a copy of it. Just select everything, copy, and we'll just paste it down here. Now, you know how we had created these aliases to identify the solenoid with the valve? We are going to have to use different aliases, because as it is now, if I press this extend, it's going to make both of these valves move because they're both associated. So just like on the HAS 200, we're going to start distinguishing between the valves and cylinders. So what I'm going to do, actually, before I do anything, is I'm going to label the cylinder. We haven't done that yet. So if I double click it, and it might come up looking like this, or there's a whole bunch of submenus. You want to go to data, and under data there's a generic name for it. It says double acting cylinder, and I'm going to call it cylinder A. And just I need to check it so that it'll show up, and that way we can start distinguishing. And also on the valve, I can do the same thing. Under data, it just says directional valve, so I'm just going to call it A, uppercase A, kind of like the way on the HS200 and I have to check that, the valves on the solenoid are all labeled. So I'll just tuck this down here. Okay, so that's valve A. This is actuator A plus, which makes it, which puts it into its actuated position, and actuator A minus, which puts it back to its regular position. So down here, I'm going to make all these B. So I've got to change those labels first. So let me just label the cylinder first. So let's call this cylinder B. Check it so it shows up. And just move it down here. Actually, I realize I'm going to have to move it down here because I'm going to put something else up here. And then this is going to be valve B. We'll just call it uppercase B. And move that label down closer to it. And then these two are going to, so what we have to do first is change the alias on the two solenoids. It's going to be B plus and B minus, and then we have to pick that off of the alias list. So if you double click this and change this to B plus, and then this one to B minus, so now we have to link the pneumatic solenoid symbol to the electrical solenoid symbol. And so we just double click, actually we can double click the whole cylinder, and the two solenoids are V1 and V2. Now through trial and error, I found out that it's easier if you got to delete both of the links before you start reassigning any links. So I'm deleting both of these. Now I go back to V1, and that's going to be B plus. And then V2 is going to be B minus. Okay, so now they're linked. Now nothing is really changed. The circuit is going to work the same as the previous one, but now I want to make some modifications to make it automatically return. Okay, actually going to move it down just a tad more. So what I want is, if you remember in the other one, the rod went out and physically contacted a cam roller that pushed a valve down and put air into the main valve. So in this case, we need an electrical sensor. So that is found, we have to go up to the pneumatic menus, and in this subcategory of sensors, there are proximity sensors, one of which is this magnetic sensor. So if you just bring this up here, you have to place it. If you see that little diamond-shaped dot just below the symbol, you have to place that on the edge of the cylinder. And so what's going to happen is when the rod extends, this is a little diamond-shaped dot that's on the piston that's going to slide up and make contact with that. And that's going to simulate in the way the real cylinder has a magnet in here that comes up, and the magnetic field causes the magnetic sensor to trip. So, all right, the alias for this, we're going to stay consistent with the HAS200 notation. So it's cylinder B. So we're going to call this sensor B, lowercase b, 1. And so now what we have to do is, that's the pneumatic symbol for the sensor. We need to create the electrical symbol in place of the retract button. So we get rid of that. And we're going to go back down into electrical control and go to sensor switches. There's a whole other category of sensor switches. And this is what we want, is this normally open proximity switch. Put it here in the circuit. And when I double click this, Now I can identify it with sensor lowercase b1 by just double clicking b1. Close the window. Okay, so now those are associated. So let's simulate the circuit and see how it goes. So if I hit extend, it goes out. As soon as it hits that sensor, it retracts. Now watch the electrical circuit when I do this. When I press extend, watch B1 on the electrical side. You see it close quickly? That's the electrical response of the sensor. So now we have an electro-pneumatic version of the pneumatic circuit in Virtual Lab 2. So let's stop the simulation, and then the last part is to create an electro-pneumatic circuit that acts like the reciprocating motion. So I'm going to take this and use most of what's here. So I'm going to copy it, go over to this area, I got to move it over a little bit. So just like before, I have to name the cylinder, give it a different letter designation, mainly because of the solenoids and the sensors over here. So first thing we're going to do is give the solenoids a new alias. This is going to be now cylinder C. So this is C plus, and this is going to be C minus. And actually we have to, well, this is just a visual label that we have, but we just want to make it so it's clear. This is now cylinder B. I'm sorry, cylinder C. So I just have to change that. And also the name of the valve, we're going to change that to C instead of B. Oops, where is it? Oh yeah, I have to click. I guess I have to click on over here. I have to click on this, and this represents the whole valve. And I'm going to change the name to C. Okay, and now the last thing we have to do, well, also we have to change the sensor to C. So everything has to be changed so it's consistent. And then the solenoids down here have to be linked to this C plus and this C minus. So just double click the whole valve, expand this thing, and we go to V minus, like a variable assignment. You have to go down to variable assignment and delete the current link on both of them. I think I mentioned I tried deleting one and then reassigning it while the other one wasn't. For some reason it didn't like it. But so now we're going to associate V1 with C plus, which where is it? Here it is. C plus, and V2, that's the actuator going back the other way, is going to be associated with C minus. All right, so there's C plus and C minus, and the last thing is we want this to be associated with C1. So we just delete B1 link, and then over here double click C1. Okay, now in this circuit we are going to replace the extend button with another sensor, and we want to make it so we have some way of turning it on and off. So what it's going to do is we're going to add another sensor on the retract end called C0 and identify that with a proximity switch over here. But we need a way of turning it on and off. So we want a normally open toggle switch. Bring that up here, and I'm just going to, yeah, it doesn't even matter what we call it. I'm just going to call it main control and I'm going to rotate it so it's like this, and we're just going to stick it in here. So when we flip that switch, it's going to apply electrical power. Now we just need to change so this is all set, the extend. We got to add another magnetic proximity sensor. So we could just copy this and paste it here so that the little diamond that little diamond dot has to be on top of the one that's there. So that's the retracted position. And we got to change the alias to C0. And then we have to get rid of this extend push button and replace it with a proximity switch, which we can just copy and paste. And this also has to be identified with C0. So we've got to delete the current link and relink it to C0 by just double clicking that. Okay, I think that is ready to go. So we do normal simulation and turn the power on, and sure enough, it goes back and forth. And just like before, we can adjust the retract speed while it's going. We can make it slow. We can adjust the extend speed, fast extend, slow retract, whatever, just like before. So here you see the electrical and the pneumatic working together. Notice how the sensors are causing these proximity switches to close. Another thing I meant to mention, they use the color coding in Automation Studio. The purple lines indicate that there's positive voltage and the green indicates 0 volts. So if I open the main switch, and I guess if it's black, it's not under any power. So that's the end of Virtual Lab 3.